The glass block was fabricated with 3 holes drilled in it. These are nominally 10 mm, 6 mm, and 3 mm diameter. An internally spherically focused probe was selected to minimize the off-axis effects. The probe used has a 12.5 mm diameter with a nominal frequency of 7.5 MHz. This compression mode element has a 150 mm radius of curvature. A refracting wedge is used to provide a shear wave beam, nominally refracted at about 55 degrees from the normal. The beam was directed at the 6 mm diameter hole, and the delay increased to 3.8 microseconds after the element has been pulsed. The mechanical pulse enters the glass from the wedge. The incident angle is greater than the first critical angle, so only a shear mode is present in the glass. After entering the glass and moving about halfway towards the hole, the pulse image is approximately 5.3 microsecond delay from the entry point. As the delay is increased, we see the pulse maintaining an almost plane wavefront that narrows slightly as the target is approached. As the incident plane, the reflected transverse wave that forms as a result of this interaction takes on the cylindrical shape of the hole as it propagates away from the reflecting surface. But at any angle away from the perpendicular, an incident shear wave at a solid to free boundary interface will mode convert, and, in addition to the reflected shear wave, a reflected compression wave occurs. The compression wave moves off in a similar cylindrical shape, but at about twice the shear velocity. The associated wavelength of the two modes, as well as their positions in time and distance from the target, can be used to verify the modes. The wavelength of the shear mode is measured at about 0.5 millimeters, and the compression mode is about 0.8 millimeters. As the shear wavefront progresses, the second critical angle is reached at the curved surface, and a Rayleigh wave forms. The Rayleigh wave is seen linked to the interaction of the shear mode with the free boundary. The linked wavefront can be considered a form of head wave, and it has the appearance of a spiral. This head wave can be seen to account for the post-cursor signals that an ultrasonic technician sees as repetitions on the A-scan, as a result of several circuits around the cylinder.